Hi, in this lecture we are going to talk about the implementation of the quicksort, and it's going to be the same as we have discussed in a theoretical section. So that's why we have a quicksort method with a nums one-dimensional array, a low index and a high index. The low index represents the index of the first item in this array. The high represents the index of the last item in that given array. And if the low index is greater or equal than the high, we return. This is the base case because, as you can see, we are going to call this method in a recursive manner. First, we partition that given nums, one-dimensional array. Then we call the quicksort recursively on the left subarray and the right subarray. And as you can see, pivot index -1, pivot index +1. So we don't bother about the pivot anymore because after the partition phase, the pivot will be in its sorted order. And all the items on the left will be sorted with quicksort, and all the items on the right of the pivot will be sorted with the quicksort again. So we are going to solve the subproblems with the help of the same approach. This is the quicksort itself, so that's why we call this method recursively. This is the typical divide and conquer algorithm. So what about partition? Partition is going to generate the pivot for us. So first of all, we generate the pivot index. We could generate random indices, but in this case we select the middle item in the given array. This is the integer division because we would like to end up with an index and not, for example, 2.6. 2.6 is not an array index, but 2 is an array index, or 3 is an array index. So this is the integer division. Okay, then we swap the pivot index with high index. Okay, then we initialize I to be the low index, and basically with the help of this, we make sure that all the items that are smaller than the pivot will be on the left, and all the items that are greater than the pivot will be on the right side of the pivot. Then we swap the nums with the I index and the high index. What does it mean? That we basically, the high index is the pivot itself. At the beginning we swap the pivot index with the high index, so we swap back the I index and the high index, and we return I, which is the index of the pivot. So that's why the pivot index will be the return value from the partition function. Of course, the swap is the basic swap, so we have two indices and we swap the two indices in the nums one-dimensional array. And this is how we sort with the help of quicksort. Let's see whether it's working fine. We just have to call python quicksort.py -2 -2 -1 -1 0 0 1 -2 -2 -1 -1 0 0 1. It is ascending order. What if we would like to make it in descending order? We just have to change it to something like this. Let's save it. Let's rerun it, and as you can see, 1 0 0 -1 -1 -2 -2, it's going to be the reverse order. Okay, so this is how we sort an array in ascending or descending order with the help of quicksort. It is a divide and conquer algorithm. That's why it can be implemented with the help of recursive method calls, and a partition is going to make sure that the pivot is going to be the threshold, in the sense that all the items that are smaller will be on the left and all the items that are greater will be on the right. Okay, if we are talking about ascending order, if we are talking about descending order, then it's going to be quite on the contrary. The left side of the pivot contains all the items with greater than the pivot, and the right side of the pivot contains all the items that are smaller. So it depends whether we are making ascending or descending ordering. So that's all about quicksort. Thanks for watching.